and we categorized them as other, and they gave some qualitative feedback. One of their main concerns was privacy. One participant wrote, always a bit disconcerting to feel like you're being recorded without permission. They were afraid that maybe their emotions would be misinterpreted and they wouldn't want false information getting to the person they were communicating with. But overall, the cited survey participants were enthusiastic about it. They thought it would bring equality to the area of social interactions. And another participant wrote, it would be similar to another person looking at me and analyzing my facial expressions with their site and trying to figure out my emotions or opinions. And then in addition to the cited surveys, we have had interviews with a few individuals from the blind community. We've had 9 so far. They've had a lot of positive feedback to give us about our project. And something interesting that we learned from speaking with them, we asked them if they preferred facial recognition or facial expression, which one was more important to them. And those that said that facial recognition was more important to them were individuals that had been blind since birth. And those who said facial expression was more important to them were those individuals who lost sight later in life because they once had the ability to recognize expressions and see emotions on people's faces, and they really wanted to kind of get that ability back. And then to talk about the next phase, I'm going to pass it on to Andrew.
Thanks, Melissa. So the next phase that we moved into after idea generation was our design phase, which consisted of both the hardware and the software element. In order to do so, we have to take into consideration what had been done before in previous research studies. So one of the things that previous research studies have shown is that the blind people like both facial recognition and facial expression analysis. So we decided to include both of those in our project. Next, we had to identify which expressions we wanted to identify. We chose these 6 expressions, which are universal throughout all cultures. So were you to take this same device anywhere else, you should still be able to work and identify these expressions. And then finally, we had to make some decisions as to how we're going to implement this. We decided to use C++ because it's real fast. We also decided to go with a proprietary facial recognition solution, as well as optical flow algorithm provided to us by Dr. Yaku. And what the optical flow does is it takes pixels from frame to frame and tracks their movement. And based on that movement, it can tell you what the expression is on the subject. And next, Michelle's going to tell you a little bit more about the hardware.
So now that we've decided on what kind of software we were going to use, we had to come up with some way that a blind person can actually use this. And we looked into several different ways, especially with mounting a camera. We thought about putting it on a pendant so that the person could hold it out and look at your face. We thought about putting a camera in glasses, as several other groups had done. And we also thought about putting them as a chest-mounted thing, because this puts them at eye level. And when we brought these ideas to the technology assessment team at the National Foundation for the Blind, they weren't very thrilled about them. And they suggested something completely different that we hadn't thought of. They suggested to mount the camera on a white cane, because this is at eye level for most people. And it also, they already carry it with them. It's not something else that they need to carry. So from there, we had to just make a decision whether we wanted to go with our initial idea of stereo vision, which would be 2 cameras, which gives a sense of depth, or the simple 1 camera. And we decided to go with a simple singular camera because it makes the algorithms easier, and we still get some sense of depth, and it also makes mounting it a lot simpler. So then we had to come up with how to mount a camera on a cane, because it's not exactly an easy thing to do. So we got these remote head cameras. So the remote head is up here, and it links to the circuit board down here. Now, as you can see, this is slightly bulky, and so we decided to actually put the 2 together in one device, as you can see up here. And the way that we were to mount it on the cane at all was a little bit complicated as well. So we decided to go with a universal mount, because if you've ever seen a tripod for a digital camera, it's a universal size screw. And we decided to go with that so that, because you're not always standing up talking to people, you could be sitting down at a table and you can simply unscrew it and put it on top of a tripod on the table. And in order to do that, we had to come up with some sort of central mounting device. And you can see that there's a wooden disc in the center and then 2 halves of sphere on either side of it. And and it's flattened in the front so that we're not limiting the field of vision. And now this will be our next step in order to get this manufactured professionally. And we've also acquired a new camera, which we will be working on mounting as well. And now we'd like to show you a little bit of what our cameras can do. Now this is the expression demo. Now as you can see, it's tracking her face. It's finding the different features and it's following them, and it will eventually output an expression. Another condition. Now this is Harrison, and he's going to actually enter his name into the computer and tell it it's taking a couple different pictures of him right now to remember his face. And so now it's announced his name and he's leaving the frame, and now when Alvin comes in the frame, it doesn't recognize Alvin because there's no picture of him in the system. It doesn't picture him as Harrison. And now Harrison's going to come back and you'll see that the computer again recognizes him. And if we had sound, it actually does say his name. So the biggest challenge that we faced is integrating these two different software with our hardware. And we've accomplished this by talking to several different experts, relying on our own expertise, and this was the final product that we had. So as you can see, these could use a little bit of improvement, and so we will be working on improving them internally as far as making them run faster, integrating them together. And once we have a product that we're happy enough to test, we're going to actually put our device in the hands of a blind user with some unique design subject tests, which nobody else has done. And there's going to be a feedback system, probably a chime that will give them some feedback on what it's giving to them. And we're going to actually ask them to evaluate it. Does it work fast enough? Is it distracting? And from this, we will take this data and we will go back to the drawing board and improve our design. And now I'd like to hand it over to Gio, who's going to talk a little bit about our future goals.
So to stay on the track with all of our ambitious goals, we've created a very detailed timeline broken down by semesters. So for example, for this semester, we've begun our surveys and interviews. We're continuing them throughout the semester. We're looking at finishing the design for our algorithm, integrating both the expression demo that you saw, the recognition, integrating those together, integrating the hardware with the software. We've also been planning for the junior colloquium. Obviously, we're on time. Next semester, we're going to begin testing our prototype both internally and also putting it to subject tests. And we also hope to begin revising our design based on these user evaluations. First semester of senior year, we'll finalize our prototype. We'll begin finishing up our subject testing, revising our design, and begin writing our thesis. Finally, our last semester, we hope to have a finalized, revised design and present our thesis. Now, at the end of this research project, we hope to answer this one ultimate question. Can such a device change the way the blind interact? Can we actually make a change? Now our goals, our ultimate goal can be summed up by a quote that was said during one of our blind interviews. It goes, the more aware, the more educated, the more able we are to make better decisions and interact more appropriately with each other. We shouldn't be looking at this world as half blind and half sighted. It's a world we all live in. We need to get along and respect each other and survive together. Now, speaking of surviving together, we have a little bit of advice for you as we begin Gemstone. So, in terms of team dynamics, you want to have a stable team structure. For us, this meant breaking it into 3 subgroups. One of us is focusing on expression, another subgroup focuses on recognition, and finally one concerns all the surveys, all the interviews. You also want to have norms that you actually enforce during meetings. Anytime conflict arises, we found it helpful to have peer mediators standing in the middle. Now, in terms of research process, what you want to do is stay on top of things, stay motivated, don't go to sleep. And when the going gets tough, remember to give Gemstone a chance. Personally, for us, it's been a great and enriching experience.